In this video, we're going to talk about the quotient rule for exponents. And hopefully if you remember from your late elementary years when they were talking about multiplication and division vocabulary, as well as addition and subtraction vocabulary, you remember the quotient rule as the solution to a division problem. So when we're working with exponents, when we're applying the quotient rule, technically we're dividing, but there's a but to that, so let's talk about that. So for this one, we have z to the 10th power and z to the 5th power. Okay, we can write each one of these in the numerator and the denominator in expanded form. So I should have 10 z's up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we're multiplying them as we go along. In this one, we have 1, 2, 3, 4, 5 because it matches with our exponent of 5. So when we're working with this through expanded notation, we can cancel because any number divided by itself, or in this case variable, any variable divided by any variable is going to equal 1. So if z was 10, for instance, 10 divided by 10 would be 1. So we can just cross cancel these out. 1, 1, z, 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 z. Okay, there's no more z's that we can cancel out to equal 1. So all of these equal 1. You don't need to write them there because that might get a little confusing. But here we have 1, 2, 3, 4, 5. Okay, 5 z's. So z to the power of 5 would be what this looks like in expanded notation. Now next week we'll talk about what happens when we have these, when the z's are at the bottom. But for right now, for this video, we have our z's up here. Technically there's a 1 under here because any number can be made the same by putting it over 1. So just so you know kind of where that comes from and where we might be going next week with that. But there's a simpler way, obviously. We have our quotient rule that tells us when we have these numbers, these exponents, we can subtract the exponents when we're technically dividing, because remember, a fraction is a division problem. But we would then go ahead and subtract our exponents. So it would be z, 10 minus 5. We start here, we start with the top one, okay? It will make a difference. So 10 minus 5 equals z would then be to the 5th power using our quotient rule. Okay, but obviously it gets a little bit more complicated than that. So let's look at something that's maybe the next level up. So we have our quotient rule here, and we have a quotient because we have a fraction that has some numbers in front of it along with our exponents. So we can't have this to a base of 10 and base of 10 and base of 5. We can't just simply subtract our exponents because the bases aren't alike. One of the nice things that we can do though is we can take this separately and just go ahead and divide it. 10 divided by 5 will give you 2. Okay, it's just that simple when the bases are not alike in this quotient rule. Okay, we can just go ahead and divide them like a normal problem. But here we have a different thing going on because we have our bases of e that are alike. So we do have our base of e, and using our quotient rule, we would take that 18 and subtract 9. Remember, always reading from top to bottom. And then we can simplify that further as 2e 18 minus 9 will give me 9. Okay, so let's get a little bit of practice with this. This is a pretty simple rule where we're just going ahead and subtracting it. So remember, with like bases, we can just go ahead and subtract those exponents. Like for instance, look at the second one that we have here. We have like bases, so we just don't take 9 and divide it by 9 at this point, okay? When the bases are alike, we subtract the exponents, okay? So oops, let me unfuzz this for you. So go ahead and pause the video, and we will come back to discuss it. All right, so let's take a look at the answers. So for this one, we have our b's, okay, our like bases are b's here. We would then take 14, subtract it by 2, and we will get 12. So it would look kind of, that intermediate step would look like that. 14 minus 2 equals 12. For this one, my base is 9. So I do need to put my 9 there, and my intermediate step would be 6 minus 3, which gives me my 9 to the third power, okay? Which would give me, if I wanted to open it up even further, this one's a nice number that we can work with easily, 729. Just be careful with this, because if you went ahead and divided this, you would have gotten 1 to the power of 3, which does not equal 729. So please, please, please be careful with those like bases, okay? But remember, when we do not have those like bases, like in here, we can just go ahead and divide those numbers. So 32 divided by 8 would give me my 4, and then I'm going to have my m, 13 minus 4, which will give me my 9. If you have any questions, please feel free to reach out to us.